Unstoppable Code. Me llamo Rafa, and welcome to the Alibre Community.
Okay. I don't know what it says. I never read it before, so yeah. So this is the thing I wanted to start with. Yeah. So what can I tell about myself? I started to do Bitcoin and related technologies in 2015 as a team member of a company called Tether. So what that company did is what we did in the company. We created a token which is pegged to the dollar, to the US dollar, 1-to-1. And so we were like taking money from users, giving them tokens, and then they can use these tokens to pay each other, and it was pegged to the US dollar, and it's one of the popular tokens right now. And then I went to another company, which is the company I'm working right now. The company is called Ambisafe. And so since the beginning of 2016, I'm doing the smart contracts and only most of the time related to Ethereum. So first I want to give a little intro into the blockchain and Ethereum, how it works, and what are the applications of it, what are the pros and cons of it, so that you can have an idea how it can be utilized and how people use it. And the thing is that I prepared this presentation. I started to prepare it before the already mentioned DAO hack happened, and I finished doing it after it happened. So initially it called it the Unstoppable Code, because that's what you can do on Ethereum. But right after the DAO hack, I decided to change it to Unstoppable Fear. Yeah, so that's the thing. Yeah. So the blockchain. The blockchain is a very simple concept. In the blockchain, you have the original state, and the state, you can imagine like you have a piece of paper, and on this piece of paper, you have some records of whatever information you want. And then you have some process by which you can change these records to some new records. So you have some input transactions that people give you, for example. Then you apply these transactions to these records, and you have a new set of records. So one set of records is called the state. Then you apply transactions, and you have a new state. Then you apply transactions, you have a new state, and so on. And usually these states, they are changing in blocks. So you can call this thing a block, which result of the block is the new state. Then you apply transactions, you have a new block, new state, and so on. So this is the blockchain. It allows us to change the state, change the records in our state. Next one. So what's the main difference between Bitcoin and Ethereum? So in Bitcoin, if we're going on the very high level, abstract level, we have accounts and we have their balance. So on this, you can imagine this piece of paper, and then on this piece of paper, you only have account, identifier, and its balance. For example, this account has 1 Bitcoin, another account has 2 Bitcoins, and so on. And what you can do with the transactions, you can change the balances between the accounts. Decrease the balance of one account, increase the balance of another account. And yeah, that's what you do. And then Ethereum, you can also have this basic thing like accounts with balances, but also you have special kind of accounts, right here, account 1, which has not only the balance, but it also has a code, which is a programming code attached to it, and the storage, unlimited storage for the records that will be only accessible and managed by this particular account. So it's like a state inside of the state. So if the blockchain itself has a state that is changing, then you have a storage that is a state inside of the one account, which is changed inside of this account. And so the next slide. So this we call a smart contract. When we have an account with the state, with the storage and the code attached to it, we call it a smart contract. Next one. So the Unstoppable Code, why are smart contracts so cool? And how they differ from the old school applications that we have everywhere right now, like any applications basically. So on the applications, they should be, they must be blindly trusted, because when you go to some site, for example, some banking site or PayPal or whatever, any other application on the web, most of them, you just trust what happens there. So, for example, you log in there, and you should believe in that the application will work as it is promised to, and that nobody, like the owners of the application, will not tamper with your account or with your data or whatever. And with the smart contracts, no trust is required, because you can see the fixed code that this smart contract operates on, and you can be sure that it will always operate as it said in the smart contract. So the code of the application is public, and if you can understand it, that you can be sure how it will work. So again, the application is might be controlled by a greedy human, and so even if the code is all right, there is always human behind it, and this human behind it might be greedy, and they might do bad things to you or to your data. With the smart contracts, again, it's controlled by fixed code and not by people, and you can be sure that it will work as it should work. So the application, again, can have downtimes. The most simple thing, like somebody pulled the code out of your server, or something happened to your virtual server on Amazon or on Google Cloud. And with smart contracts, as soon as you deployed it into the blockchain, it is, from that point on, it is always accessible as long as there is internet and as long as there is at least one node of Ethereum running somewhere and you have access to it, as your application will be running. So again, the life of the application depends on the life of the server. So if at some point of time, like all your servers are broken, then your application is dead. And smart contracts depends on all these Ethereum nodes that run across the world, and there is thousands of them. So it's much more durable. In the application, so even if the application is right and the humans behind it are trusted and not greedy, somebody might get into the server and break things up. With the smart contracts, nobody can do that, because again, it's controlled by fixed code, and the changes and how things are moving forward are controlled by the process called the consensus, which means that everybody agrees on how things changes. And so applications are paid, so you are the owner of the application, you need to run the servers, you need to make sure that you have enough traffic and everything. And with the smart contracts, it's usually paid by users, because in order for somebody to interact with a smart contract, they need to pay a fee of interaction with it, and that's how the network operates. Then again, if you want to have a history of, for example, you have a database, or you have a bank and you have a database, and you want to know at some point of time what happened in the past, so what you can do, you can set up backups from time to time, but there will be usually there will be some times between the snapshots that you're doing in the database. And when you're working with the smart contracts, every single change that happens to this set of records inside of the smart contracts, every single change gets recorded in the history, and you can always access it if you want, if you're running the node, or if you know somebody who runs the full node, and like all the history is recorded and verifiable that it can only happen in this particular way. And so applications has tons of code which sometimes might not be good, and the smart contracts have very limited code because of a few reasons. And so for the user, for example, if he wants to make sure that everything works as he expects, he can have like limited amount of code to understand and read. Now, what's the problem with all this? So on the applications, that's a very cool thing that you can do. It's a hotfixes. You made some problem, you just found out about it, you just deploy a fix in 15 minutes and problem solved. With smart contracts, we have fixed code. You have a problem forever. Now, in order to fix it, you just need to redo the whole application from the beginning, and if there was some data in the old one, well, probably it's all done with it. So the applications, again, are easily upgradable as it evolves. Like, for example, our Alibre applications, you add the new functionality over and over again all the time. It's a never-ending process. And with the smart contracts, we have a fixed code. So basically, you need to put everything you want inside it and make sure that it will be good for forever. Then, in the application, you have a database on a server. You want to do something, you want to migrate, you just take the storage, you move it to another server, everything is cool. With the smart contracts, you have a fixed storage tied to the account, cannot really move it, cannot let any other smart contract change this storage. So if you have the storage and the code that is changing it broken, then you cannot do much to the storage anymore. And for example, even if you just want to copy the storage from one smart contract to another, you can do that, but it will be very, very expensive. The more storage you have filled up in a smart contract, the more expensive it will be to move it. So in the application, you can close the application in case of the disaster. You find out that you have some broken thing, you just put a maintenance page on top of it, and everything's cool while you're working on the hotfix. With the smart contract, it's always online, nobody can stop it. So if there is a problem, the people will just make use of it. They will start exploiting the problem, and you just cannot stop it. And again, with the application, so for example, you found out that in your bank records, the code were broken and something happened. So you found out that changes made to the account balances were incorrect. So you decided that you want to roll back to some previous snapshot, then fix the code, then reapply all the changes, and the balances will be all right. With the smart contracts, we have consensus-proved irreversibility, so everything moves only one direction. In case something broke in the middle, well, it will be broken forever after. Application is free for the users most of the time, if it's in terms of the maintenance of the application, not in terms of the making profits or whatever. It's just for the user to use Google, it's free for them. For the users of smart contracts, well, they have to pay. Most of the time, users have to have some money and every time they want to use an application, they have to pay for it, which might not be a very good thing for many users, or most of them. In the application, you can conceal the data. You can literally take the sensitive data from the users, make sure you store them in a secure and concealed way so that nobody have unauthorized access to it. In the smart contract, if you put something into it, it becomes public to the whole world right away. So you need to be very careful with what you put into the smart contracts, and always remember that it will be public. So it limits the possibilities of what you can store there, and yeah. Again, applications can be of unlimited complexity. You can imagine the Google or Facebook or whatever other application, they just have tons of code, and they are ever growing in complexity, and they're becoming more useful to users because of this. And with the smart contracts, well, we have limited code, because you cannot ask all the participants of the network in the world to run something so big that it will just not run on their machines, because their machines will not be powerful enough. That's why you have very limited amount of logic that you can put into the smart contract. Well, so this is the cons. So the usages, let's do it 4 slides forward till it fills up. Yeah, so what you can do, for example, if you know how in casino how roulettes work, or how the spins work. So every spin in any casino has this parameter called something like payback or something. So it's usually set to around 90%. So whenever people play with it, they always get about, on the statistical amount of time, they always get about 90% of their money back to keep it enjoyable. Because if you lose all your money after every spin, then nobody will play it. And so about the 90% of the money is always returned to the users, and only 10% is stayed with the casino. And they can change this parameter from time to time, but usually the people who play spins, they should know about it, and it's just a fixed parameter. But so somebody, of course, can win, but in the total, 10% will be taken by the casino. And But some casinos might decide that it's not good enough, and they might put like lower percents, like 80%, 70% going back to users. And if the user wants to make sure that, well, if he already plays casino and he plays spins, he probably knows that it's like a money-wasting process, but at least he might be sure by looking into the smart contract of the spin that it actually gives him 90% payments back. Let's go next. Yeah, so voting-based decisions. So the most common one is if you're using the assets that are present inside of the blockchain, inside of the Ethereum, you can control these assets by the smart contract. So you can say that these particular assets can be moved after this and these conditions happen, and they can be moved to that place or the other place. And even easier, you can just have a couple of people, like for example, you have a family and you have a family budget, I don't know, family backup budget, and you want to be able to move this budget in case of emergency, but you don't want any single member of family to be able to just like take the money and run with it. So you set up a smart contract which says that you have a family of 7, for example, and you want 4 of them to agree in order to move any funds at all. So they will have to work together to agree to receive agreement of 4 of them, then prove to the smart contract that they agreed, and then the smart contract will move the funds. So again, in the same way, you can have, for example, some investment fund, and to make the decisions of where to put money, you're using the same process. Like you put the rules of how decisions made, then the participants, by interacting with the smart contract, they're contributing to the decision making, and voila, you have the decision. Well, yeah, the product control, for example, again, it can be made in a way so that you put some application that listens to the smart contract. And this smart contract issues the orders, like what the application should do, like some normal life application, old school application. And so again, you have this voting process between some, I don't know, managers or the admins of the company, and they are voting on how to change the configuration of the application, for example, and the application listens to it and only does the change when the consensus is achieved between the admins of the application. And so yeah, and that's also a thing about the general decision making, like how people do it in the real life. They just sign paper, like voting on the paper. They can just move from the paper and go to the blockchain and do their signatures and decisions in the smart contracts without using the paper anymore. Next one. Yeah, so interpersonal contracts. So the thing is that you can make a smart contract that will describe how the different parties interact with each other. So even with the simplest agreements, like you have eBay when somebody puts something on sale, and then you can buy it, and then they need to send it to you, and so you can have different incentive algorithms, how to make people trustworthy and how to force them to act in a fair way. And again, as everything is happening inside of the smart contract and the actors are known to the smart contract, they have identifiers, you can have a reputation of these actors, and you see the whole history, so you know that nobody can, for example, nobody can ask eBay to set their reputation to some high values, and because you can verify the whole history and how they achieved this reputation. Then again, premarital agreement or whatever agreement, you can just put whatever text or agreement or something into the blockchain, sign it by the parties that are taking part in the agreement, and then it will be there forever. It will not ever be burned, some in the fire, or it will not be lost, and so you can just put it there. Let's go next. Yeah, so general written contracts. Just instead of doing it on the paper, you can do it on blockchain. Instead of signing it with the pen, you can sign it by your transaction on the blockchain. And so this is the story that happened in the rise of Ethereum in the spring and summer 2016. So there was this idea which was presented even before the Ethereum was released. The idea was of the things that are called decentralized autonomous organizations. So the idea is that the idea of the DAO was that you have an unlimited set of people who are all the shareholders of this organization. And they are together can do the decisions where put the money of this organization to, where to invest it, and then like if there is any return to get the return spread amongst the shareholders. And everything is managed by the smart contracts. Again, of course, people are involved in it because they need to make decisions, but in order to make it transparent and verifiable and robust, it was all put into the smart contract. And yeah, so on the May 1st or about so, project released it and started to raise money, like to fill up the fund and to allow participants to buy the shares of the fund so that later they can decide where the funds will go to what other projects. Next one. So by June 1st, like in a month, they raised $150 million by all the different people who were so excited about the idea. And, oh, that was too fast. Okay. Next one. Yeah. So on June 12, the minor bug in contract found by the officials and announced that funds are secure. And even the developers of the Ethereum, they made a blog post about particular set of bugs that one particular bug that might be common among the smart contracts that can be exploited in some particular way. But it was thought that in this particular smart contract, everything was fine. But then, on the next slide, on the June 18, somebody exploited this bug to take out $50 million in very short amount of time. And after that, all the people understood why the bug was not so minor. But as I said before, in the blockchains, usually in Ethereum, also we have this irreversibility. So whatever happens just stays there. But if you have most part of the community decide that no, it wasn't a good thing to happen, then most part of the community, or actually all of the community, may decide, okay, let's do some change that will undo something that happened in the past. And so, yeah, part of the community agreed that they should undo this $50 million loss, and they updated their software to follow the new rules. And so consensus proof strikes back, because people have a consensus to undo the thing, which is a rare event, but still it happened. And well, it all was rolled back, and the money of the fund were just returned to all the participants. Well, it was in the process of returning it all to the participants of the fund. So that's the thing about the smart contracts and Ethereum, and it's I'd say, old history of Ethereum, because this is what happened in the summer 2016. Any questions about this thing before I proceed a little bit further on our current developments? No questions, okay. Let me check. How much time is there? Okay, 25 minutes through. Yeah, so what we do and how we do it in Ambisafe company currently since 2016. So we are specialized in building the applications on Ethereum. So we're issuing different tokens. Yeah, I will say a few words about the tokens. What are tokens on Ethereum? So the token is just a smart contract that has its own records of who has how many tokens. And so whenever you want to send your tokens, there is no such thing as sending anything inside of the smart contract. What you do is you say to the smart contract, I want to lower my balance and increase the balance of somebody else. So what the contract does, he has this state, which is just a database, and lowers the balance of one account and increases the balance of another account, but in fact nothing gets sent anywhere. It's just the changes in the records of the smart contract. Even though for the people, it's usually more understandable when you have a concept of sending, because, well, nothing gets sent, nothing gets out of the smart contract even, because there is no external interaction, not even smart contracts interacting with each other. You're just changing the record. So yeah, what we do, we issue tokens. The tokens are a popular thing on the Ethereum. And then you can give these tokens different properties from real life, for example. So as I said with as I mentioned in the beginning about the Tether project, so they receive the US dollars from people and they give the people tokens in the same amount. So they receive it 100 US dollars, they give out 100 tokens. And then the users can change, like send these tokens to one another, and then at some point they decide that they want their dollars back, so they go to the Tether again, they send their tokens to the Tether, Tether gives them their dollars, and everything is fair. Still, it's not you cannot call it a truly decentralized system because you have one single company that holds all the money, and in one single bank account, probably. So if their bank account is wrecked up or the founders just decide to run with the money, well, then your token's worth nothing anymore. But still it is trustworthy, it's very helpful and useful, and community likes it because it's stable. What other things? We did a project, like we helped to in 2017, which is called the Propi. Propi, the idea of the project is to let people sell or buy the real estate, like houses, overseas or in another countries without actually leaving their computer. So previously it was impossible because you always had to sign the documents in person and usually at the place where the real estate is positioned. But so they are working hard to make it possible to do it from your computer. And so what they did is they worked with the local authorities, with the governments who manages the property ownership rights. And they are putting so they have the smart contracts which manages how the property is moved from one owner to another one. But still there should be a paper somewhere saying that, well, this transfer happened. But still what they did, they put the hash from the information from the blockchain inside of this contract, inside of this paper contracts, as a information and as a proof that the one owner actually signed the sale and another one actually received it. And so they not require the buyer, for example, right now to go anywhere because they persuaded the local governments in some places to accept these proofs as a physical signatures, and so it works. And the smart contracts regulate how the process is going. Then another thing that so the mission of the Ambisafe company is to let anyone in the world have an access to the financial instruments and like fintech world, and to be able to invest, for example, because like I'm from Ukraine, and before all this blockchain stuff, in order for me to like do any investment at all, I only was able to put money in some local hedge funds, which are usually, like, again, you cannot control anything, you cannot really see what they do and like how they operate. And so one of the things that we are working right now is to let people participate in the private companies' sales. So, for example, you have a SpaceX company, and they are a private company, so you cannot buy their shares just through some broker on a public exchange because they are not selling it there. So they had some private fundraising rounds. So they like found people who decided to invest in SpaceX, and they offered them to do so. And even if I wanted to participate in this private sale, I would need a lot of money because they are not interested in like a couple $1,000 investment from somebody. It's just too much paperwork. And so if you wanted to participate in a private sale, you needed to like have big amounts of money, which is impossible for me at this point, for example, or for many other people in Ukraine. So what we are trying to do right now, we are collecting the people who want to participate in, like who want to acquire the shares of the SpaceX, and we're making a smart contract that allows them to put their money into the smart contract, then receive the tokens, which will say how much money they put into the smart contract. Then we give the money raised to the private fund, which is a public company registered in the US, and like all legal and transparent. And then we ask this private fund, after collecting a lot of money from many people with little amounts of money, to go and buy the shares of SpaceX from some private person who already did that before. They need to find this person who will be willing to sell their shares, but it is a possible thing to do. And after that, they will be having these shares inside of that company. Well, again, not very decentralized thing because they are controlling everything, but people can see at least who has how much tokens and who has the shares of everyone. And then these people who received the parts of the share, they can, first of all, they can already trade with each other. So they can like hold their part for some time. They can sell it to other people if there is anyone willing to buy. But what happens in the end? So in the long run, this company that holds the actual shares, it goes again either when the SpaceX goes public, it sells all the shares it has, and it might be either if SpaceX went good and the shares price was better, or they were going lower, whatever. They sell all the shares and give the money, received money back to all the shareholders, of the small shareholders, the ones who might have invested like $100 or something, proportionally to how much they invested. And so in this way, you're not actually like, by your investment, you're not actually giving the money to SpaceX to develop, but you're still holding their shares. And before you wouldn't be able to do so, but you can do the same thing without blockchain, but with lots of paperwork. And what we want to do to allow people in Ukraine, for example, to go and buy these shares without leaving their computer and, yeah, like participating in SpaceX. And this is not an investment advice, like just to make a point. But still, I think that's a great thing. What else? Yeah, one thing about how we develop our applications. So when you do something related to money, when you do old school applications, it's always, so for example, you have a bank or you're a PayPal, it's always you who are responsible for what happens to users' money. And if you're working with crypto, and like if you want to protect ourselves, so we, for example, as a company, we want to protect ourselves so that users cannot come to us and say, you stole our money. So what we do, we are developing it and making the architecture in a way that we never touch users' money. And the blockchain allows you to do that because users have their keys and we don't know their keys, and without their keys, we cannot persuade the smart contract to move the assets anywhere. So if you design the application in a way that only your users are controlling their money, then you cannot be liable because you can prove to them that you didn't have access to their keys, and so you cannot move their funds. In contrary, you take PayPal, and PayPal can just change the records in the database and move the funds of any people to any other people, and well, they will be liable, not us. This, on the contrary, gives some problems to the users. Because if your key is controlling all your money and you lose your key, then you cannot control your money anymore, and nobody can. Because you always have a balance between like either having access at any time whatever happens, but that's like PayPal, because you can always prove, you can come in person and say, hey, here is me, here's my documents, here's my passport, give me access to my account. And, or if you really want to control it, like you have the only key, which is there, then if something happens to the key, well, you don't have access anymore. And then you need to find the right balance, how to like either make a backups of your key, like duplicate it in a couple places. But then the more copies of the key you have, the more possibilities for this key to get compromised, because somebody might find your backup. And yeah, so we, for example, we use this thing of, we're using some other third-party companies to allow users to restore their keys. So we, for example, as a company, we cannot restore their keys by ourselves, but if we are collaborating together with some other company, which is our users also trust, then by working together, we can restore users' keys. And the idea is that user will be compromised only in case both companies, we and some other third party, will be like hacked. So for example, our servers hack it, user is okay, because he only he knows his keys, and we cannot recover his key, we cannot restore it. So that other company hack it, okay, user still okay, because we are not hacked. In a rare event when both we and that other company hack it together, well, then the user is broken. But we allow user to forget his password, because that's what users do. They just forgot their password, and then they don't have access to their money. And that's the hardship of the technology, because people are not yet educated enough in such a high responsibility, because they always think, oh, okay, I forgot my password, I just click forgot password, I will get an email and I will get access back. But no, that's not how it works. If you can do that, then you're not having access in the first place. Somebody else has the access who can restore it to you. So yeah, there is lots of, since the beginning of Bitcoin and since the beginning of Ethereum and other projects, there is lots of effort going into like educating the people how to manage their keys. And because lots of people lost lots of their funds because of some mistakes or forgetting things or losing things. Yeah. Let me check how much time do we have. Yeah, I'll have like 5 more minutes, but maybe we have some questions. I can tell some other funny stories also about the old history of Ethereum if there is no questions. Just, yeah.
Okay, so you said Profi
Yeah.
is using, thanks to the help of the government,
Yeah.
someone would buy the property and then the government would say to the purchase of the contract that
Yeah.
there's random people on Ethereum that there's potentially going to be ownership of this property.
Not random people, because they are required to know the identity of the buyer too. And so the Profi, they are requesting your identity information, like your passport and stuff, but they are not like they're requesting you, for example, to send the scans to them, and then they can prove to the government that this person is buyer, because they have all information from you.
Let's say I want to sell my property to random people on the internet.
Yeah.
I write up a contract. Is there a way that I can write a smart contract to encrypt basically the ownership paperwork of property, so it can decrypt it with a private key or something?
Mm-hmm.
So I could say to this contract, okay, encrypt the real ownership, and then split off the property, let's say in a token sale or whatever. And then if these people ever want to sell, they come together and the contract spits out the ownership, and they can sell that to whoever. It's like a blank check. Is it possible for an Ethereum contract to have a private key that they can stay encrypted and encrypt that?
No, so the thing is that, as I said, anything the smart contract has access to, like for example, if smart contract needs to have access to some secret information, and if it does has this access, that means that everybody on the network has the access to that secret information. So the only way, you can put some encrypted information inside of the smart contract, but the key should be outside, and the smart contract will not be able to get the contents and will not be able to like do something with it. But at some point of time, when you want to prove to the smart contract that you, for example, have a key, or you know this and this encrypted information, you can like present the key at this point of time. Everybody will know it, but maybe so if it's one-time use key, you will prove to the smart contract that you know it. The smart contract will verify it inside of itself, do the decryption process and verify the data inside, and like for example set you as the owner, or like use this proof for something. But in case of title sales, so the main problem would be different. So the main problem with what Propi does right now is that there is always one root ownership manager. So it's usually some local government authority who actually has a database which says, or some paperwork which says that you are the owner and not that guy with that address on Ethereum. And so even if you do all this stuff and they like don't agree with it, then like nothing really happened. So the main problem, like which might be solved, is to make a process by which this local authority will pass the actual ownership management into the smart contract, and they will stop responding to any inquiries made outside of that smart contract. So they will say, okay, we are not managing this particular title anymore. It's managed by that smart contract, and we are not doing it anymore. And so you cannot go to the courts with us like to say that you didn't sell it, because as from the point you move the ownership management to the smart contract, like it's liable. But there is no such process yet. I don't know if there will ever be this process, because again, like if you did that, for example, and then you lost your keys, well, you cannot prove that you're an owner anymore. Like you need to have many backup plans how to make it robust and fail safe, because well, it's a hard thing to do. And I don't know which government authority will accept that as of now, maybe later.
Regarding that question, Tulum city is actually making a plan to put this digital certificate of a property on blockchain with the help of a company called Medici Land Governance. Have you heard of it before?
No.
That's the next plan here in Mexico.
Yeah, well, that's great. Like, but again, so they can do this already. So, for example, you have your house ownership certificate. You can digitize it and put it into the blockchain so that it's accessible. And, for example, other people can verify that you're the actual owner right now. But in case something happens to this paper thing, or like you decided to sell your property and you're not an owner anymore, and nobody updated the information in the blockchain, it becomes just useless there. And like the problem is that people cannot use it as like a main source of trust, because they don't know if anything happened with the paper. So in order for it to be like truly powerful, this record in the blockchain should be the main thing. Like if that happens, well, it will be interesting, but I don't think anytime soon.
It takes time, isn't
Yeah,
it?
anything takes time.
Which do you think is the most interesting application of the smart contracts right now?
Well, the one I really like is the voting applications, because voting, even though I might not like the ideas of democracy or some other like political systems, but the idea of the voting on blockchain is like a really transparent thing. Like you cannot really fool it as long as you have a way how to have a user's identity on the blockchain. So if you have like, for example, a limited set of people, like not in terms of like some huge country, like you have 1,000 people, a community, like local community, you like make an account, like everybody makes an account on Ethereum, and then everybody makes a picture of themselves with the address of this account, so kind of to prove that they are the owners of this account and they did it by themselves, and like there you have a proof that they are. And then you give the rights to vote for every of those accounts, and then you can vote for whatever decisions you need to make inside of the community in the smart contract. And so you cannot fool the counting system. The votes will be counted always in a proper way, because everybody can see the history of voting, and you can develop different ways you can do anonymous votes so that the voters are anonymous till the end of, till the calculation point, or you can make it open from the beginning, or whatever. The thing is that it becomes transparent and unexploitable. So as it happens with all the votings in the world, in all the countries and everywhere. Yeah, so this is the one application I really like, and the thing that's easily achievable with the smart contracts is transparency. So whenever you want to make some process transparent and trusted, you just need to put the core information about this process into the smart contract and make sure people can see how it evolves. Yeah, so I think this is one of the best things. Other one is also all kinds of financial things, like exchanging value inside of the smart contract is a cool thing to do, and it doesn't require the trust of the banks. It has some other problems in terms of scalability, for example, and in terms of keys management again, but well, I think not being forced to trust somebody is also a very good point of the smart contracts. Yep.
In continuation to that, did you see any country adopting population-wide voting system?
Population-wide, no, but even in Ukraine, we had so we developed back in 2016 again. We developed a set of smart contracts for voting, and it was tried in one region of Ukraine, in one regional center of Ukraine. The local government were doing actual votes on the blockchain inside of the smart contract. Well, and it actually worked. I'm not sure where it led, the adoption of it. Maybe it stayed in the trial period and never moved from it. But at least we know that it's working, and people were able to use it, and everything was transparent and secure. But no, I think the Estonia maybe is closer than anybody else to doing something like voting nationwide on blockchain, but as far as I know, they are not there yet. Okay, actually I think that's the time. Thank you so much.